In the previous session, we looked at arithmetic progression. Now let's look at arithmetic series. The sum of all the terms of a sequence is called a series. So S sub n, meaning sum of n terms. So S sub n is equal to a1 plus a2 plus a3 plus dot 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 plus an. Now this can become very difficult to write every time. So we have a shortcut as well using the sigma notation. So here we have the summation notation, that is sigma k is equal to 1 to n of a sub k. So here k's value keeps going from 1 to n in increments of 1. So a1 sigma means plus. So a1 plus a2 plus a3 and so on up to an. So what is the value of 1 plus 2 plus 3 up to 100? Or in short, summation as k goes from 1 to 100 of k. Now we could actually start doing 1 plus 2, 3, 3 plus 3, 6 plus 4, 10 and so on. But a better way is like this. We write down S is equal to the series. Then we write the same series in the reverse order. So 100 plus 99 plus 98 dot 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 plus 1. We add these two. What do we get? We get 2s is equal to 101, 99 plus 2, 101, 98 plus 3, 101, and so on up to 100 plus 1, 101. So how many times this 101 appears? It appears 100 times. So we can write it as 2s is equal to 101 times 100. And 2 we can bring it to this side so that we get 101 100 by 2, which is equal to 5050. So here we can write it like this. Summation as k goes from 1 to n of k is equal to 5050. So now let's try to arrive at a formula. In general, given an AP, that is arithmetic progression, S sub n is equal to a plus d plus a plus 2d and so on up to a plus n minus 1d. Now, just like we did here, we are going to write it in the reverse order. So Sn is equal to a plus n minus 1d plus a plus n minus 2d plus a plus n minus 3d dot 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 plus a. And we add these two series. We get 2 times S sub n is equal to, here we have a plus a, 2a plus n minus 1d plus a plus a, 2a plus n minus 1d plus 2a plus n minus 1d. So you notice all these terms are the same, just like we had 101 here. So now 2 times S sub n is equal to, this term appears how many times? N times. So n times 2a plus n minus 1d. 2 we take it to the other side. We get S sub n is equal to n times a plus n minus 1 times d divided by 2. So here 2a we have split it. So this term a plus n minus 1d is nothing but the nth term, which is the last term in the series. So we can write it as S sub n is equal to n times a plus l, which is the last term. So this becomes our formula. Now let's do this problem using this formula. So we have S sub 100 is equal to n is 100 times a is 1, the first term, plus 100 is the last term. So 100 times 1 plus 100 by 2, which is 100 times 101 by 2, which gives us 5050. Okay. But what if we want to find the sum from 50 to 100 numbers? So summation of k is equal to 50 to 100 of k. Now here what we can do is take the sum of 1 to 100 numbers, and from that we subtract the sum of numbers from 1 to 49. The remaining would be what we require. So let's do that. Using the formula, we arrive at this 100 times 1 plus 100 by 2 minus 49 times 1 plus 49 by 2, which gives us 3825. Now again, if we could arrive at a formula for this as well, it would be nice. So let's see how we can do that. So let's begin. S sub n is equal to the summation k is equal to 1 to n of k is n times 1 plus n by 2. Now for n and x in the set of natural numbers and n greater than or equal to x, we want to figure out what is s is equal to summation k is equal to x to n of k. So let's see. So we basically use the same approach. We take s is equal to summation of k equal to x to n of k is equal to summation k is equal to 1 to n of k minus summation k equal to 1 to x minus 1 of k. So we again use this formula itself. So s is equal to, here the first term is 1 and last term is n. So n times n plus 1 by 2 minus, here the first term is 1 and last term is x minus 1. So we can write, if we evaluate this by substituting it in the formula, we will end up with x minus 1, because we will have x minus 1 times x minus 1 plus 1. So evaluating that, we will get x minus 1 times x by 2. And combining them, we get n square plus n minus x square plus x by 2. And factoring it, we get s is equal to n minus x plus 1 times n plus x by 2. So let's use this formula to evaluate this problem. So we have s is equal to n is 100 minus 50 plus 1 times 100 plus 50. And if we evaluate this, we get 3825, the same answer. So that was arithmetic series. If you found this session helpful, don't forget to like, share, and subscribe. Questions, suggestions, and comments are always welcome. Thanks for watching. See you in the next session. That's it for now. Bye.